Right now, you are standing on top of a monster. It is thousands of degrees hot. It is under more pressure than anything you will ever touch. And it has been alive in its own way for 4.5 billion years. You call it the ground. But the ground is just the skin. Beneath your feet is a structure so violent and so strange that if you could see it directly, you would probably never walk outside again. Scientists spent over a century figuring out what's actually down there. They never dug to it. They never touched it. They listened to it instead. Here's what they heard. Start with where you're standing. The crust. It feels solid, permanent, endless. It is none of those things. Under the oceans, the crust is thin, sometimes only 5 kilometers deep. Under continents, it thickens to as much as 70 kilometers. That sounds like a lot. It isn't. If Earth were the size of an apple, the crust would be thinner than the skin. You live on the thinnest, most fragile part of the entire planet. And it's cracked. Not in one piece, but in about 15 major pieces called tectonic plates, floating like broken pottery glued back together. They move. Slowly, constantly, about as fast as your fingernails grow. You don't feel it most days. But every earthquake, every mountain range, every ocean trench is the sound of those plates grinding against each other in slow motion. Why don't they just sit still? Because of what's underneath them. Beneath the crust is the mantle. And this is where things stop making sense in a comfortable way. The mantle makes up 84% of Earth's total volume. It is nearly 3,000 kilometers thick, and it is rock, solid rock, except it flows. This confused geologists for decades. Solid rock that moves like a liquid seemed impossible. Then, in the 1930s, a British geologist named Arthur Holmes proposed something radical. He suggested the mantle moves through convection, the same way water heats and rises in a pot on a stove. Extreme heat and unimaginable pressure make the solid rock behave plastic over long periods of time. It doesn't melt. It creeps. Millions of years pass, and mantle rock shifts a few centimeters at a time, dragging the crust above it like a conveyor belt. That conveyor belt is why continents drift. It's why the Atlantic Ocean is getting wider every year. It's why the Himalayas are still rising. You are riding on a slow-motion current of molten rock, and you've never noticed. Keep going down, past the mantle at about 2,900 kilometers below your feet. Everything changes again. You reach the outer core. Here, the temperature reaches roughly 4,000 degrees Celsius. Hot enough to liquefy iron and nickel completely. This is not solid rock anymore. This is a churning ocean of molten metal, thousands of kilometers deep, spinning slightly faster than the rest of the planet. And this is the part that should genuinely unsettle you. That spinning liquid metal generates Earth's magnetic field, the same field that keeps you alive. Without it, solar wind, streams of charged particles from the sun, would strip away the atmosphere entirely. Mars is proof of what happens without the shield. Billions of years ago, Mars likely had a thicker atmosphere and possibly liquid water on its surface. Then its core cooled. Its magnetic field collapsed. The solar wind tore its atmosphere away, layer by layer, until almost nothing was left. Earth's outer core is still spinning, still generating the invisible shield above your head right now. You've never seen it, never felt it, never thanked it. But it's the reason you're alive to read this sentence. Go deeper still, and you reach the inner core. This is the strangest layer of all. It's about the size of the moon, made almost entirely of iron and nickel, and its temperature rivals the surface of the sun, somewhere around 5,500 degrees Celsius. By every normal rule, that much heat should mean liquid, even gas. Instead, the inner core is solid. How does that work? The answer is pressure. At the center of the Earth, pressure reaches over 3.6 million times what you feel at sea level. That pressure is so extreme, it forces iron atoms to stay locked in a solid structure, even at sun-like temperatures. Seismologist Inge Lehmann discovered this inner core in 1936, using nothing but earthquake wave data recorded on the opposite side of the planet. She noticed something odd in how seismic waves bent and slowed as they passed through Earth's center, and she correctly deduced there was a solid layer hiding inside the liquid outer core. No one had seen it. No one ever will. She proved it existed using math and patience. And here's something researchers are still investigating. Recent studies, including work using seismic data analyzed by scientists like John Vidal, suggest the inner core doesn't just sit there. It appears to rotate slightly differently than the rest of the planet, sometimes speeding up, sometimes slowing down relative to the surface. Some data even hints its rotation may occasionally reverse direction relative to the mantle above it. Scientists are still debating exactly what this means. But the idea alone is enough to sit with for a moment. There is a solid iron sphere the size of the moon at the center of your planet, and its spin doesn't perfectly match your own. Now step back. All four of these layers, crust, mantle, outer core, inner core, have existed since Earth was young, forming when a molten planet slowly separated by density, heavier elements sinking toward the center, lighter material rising toward the surface. That process is called differentiation, and it happened over the first few 100 million years of Earth's 4.5 billion year history. You live on the result of that ancient separation. The heaviest material ended up locked at the center, spinning and radiating a magnetic shield. The lightest material ended up on top, cool enough for oceans, forests, cities, and you. Every layer beneath your feet is doing something right now. The crust is cracking and drifting. The mantle is flowing like unbearably slow syrup. The outer core is spinning molten metal into a magnetic force field. The inner core is sitting in impossible heat, locked solid by pressure, spinning slightly out of sync with everything above it. None of it asks for your attention. None of it needs you to notice. But next time you feel solid ground beneath your feet, remember what that word actually means here. Solid is relative. Beneath you is liquid rock, liquid metal, and a slowly spinning iron heart running a shield you can't see, over a world that only feels still because you're standing on the thinnest, quietest part of it.